Yeah, I made mistakes because I grabbed this page from the department in the morning, and it says in the basement. That's the wrong information over here. Okay, so I hope the project works. Yeah, I need to turn off the lights. Where are the lights? Some lights should be off. That's too dark. The front one. Right? Just turn off half of that. That's not visible. Yeah. Okay. All right. I don't know whether I wish to use my computer to teach so I can record my notes and post it. Yeah. That's good enough. Okay, that's good enough. All right, so how can I teach this course? I'm going to do my best. I record my lecture notes, even the video, okay? So I will post even to YouTube. I do my best. So it's required you attend the lectures every time, okay? It could be online, could be in class. I will pay attention to your attendance. So if you really watch online, I suggest you to, on the comments, you type your last name of, doesn't matter, because nobody knows who you are, only me. You can type your last name, say comments, so I can see you watch it. Now, there are several students who are pretty overconfident, so they believe they can study the book by themselves. Until it's too late, they find out, oops, it's hard to digest the material. Math 166, the difficult part is not the first part. After exam 1, the second part is really difficult. You can talk to some students. If some students here maybe retake the course. The second part is difficult. The reason is you probably not well trained in proofs in the high school, in the middle school when you do exercise. Most of the problems you did in high school, middle school in mathematics, just do the calculation, find the area, solve the equations. Okay, there's no training like how to prove some statement. Okay, so if like how to prove the formulas, you're given the formula. So you've never been trained like that in mathematics. So it will be very difficult to put the right words there to give a proof, like whether the sequence is convergent, whether the series is convergent. Okay. So I strongly suggest you to attend my lecture, either online or in class, and then you start to do the homework or summarize whatever you understand. Okay, then you take the notes. It's important to organize those key points, important facts in your own way, so you can memorize them, and there's some ideas like this kind of problem, how to solve it. So you cannot just do a couple problems and come to the class. When you started to get 7 points out of 15 on the quizzes, this is a bigger warning. Unlikely you're going to get a B. Probably get C or C minus in this course. So you have to have a serious, talk to yourself or talk to me, how to improve it. because I don't want you to waste money and time in this course or retake it, okay? So this is my suggestion. So if you, I do not specify something about attendance in the class. I say attendance will be not required, but I do pay attention to the attendance. There are some students in last semester came to my office, begged me, say, can I get a C instead of F or D? I said, that's, any way I can do for you, do something like that. So I look at attendance. I did not see you very often. You only attend 1/3 of the classes. Okay, there's no way you can do it. It's something, right? You cannot prove you work hard, right? He couldn't show me the homework he did either, okay, because he did only few of them, okay? So it's I think it's the most important thing to pass this course, get the grades you want, is to do more exercise and attend the class and review the material right after the class and summarize the key points in your own way, and you'll be okay. Okay. So the first chapter 6, chapter 7, that would be not difficult, just like a math 155. Okay. And then only the chapter 11 will be challenging to some students. Okay. That's wonderful technology. It's shifted. I cannot do anything. Somebody has to do that later. Yeah, totally enough. They move to the other side. I don't know. Yes.
Has the class Canvas page been published yet?
No, not yet.
I did not see it on Saturday.
Sorry, not yet. I forgot to click the publish. Okay, I already post the syllabus and the homework assignment, but I just forgot to click the publish. Okay, I will do that after lunch. Okay, so I will post my notes over there, and also maybe send an email on regular basis about my video lectures. Okay. Oh, it's already recorded. All right, so today's lecture is about inverse function. And of course, there are derivatives. Well, whether a function has an inverse, this depends on the behavior of the function. If the function is an one-to-one function, means either increasing or decreasing, then you can define the inverse. So here's the idea. Okay? So how do we define the inverse? So you give a graph of a function. Okay? If the function is increasing like that, and here's a domain. Domain is A and B. And then range is C and D. Okay? So this is y-axis, this axis. So y equals f of x. So if it's increasing, means given x value, you can always get the y value, right? That's given by this formula. We want to reverse this procedure through this curve. Okay. So what I'm going to do is, I given a y value, can I find the unique value of x corresponding to that? Sometimes yes, sometimes not. So if the function is the increasing function, you can, this system says that if f is 1-to-1, means either increasing or decreasing. Okay, then the inverse exists. Okay, so let me explain to you. What does that mean? Okay, so you can here the function itself. So for a function means you given x, you get the y value equals f of x. You want to reverse this procedure. Given y value, I want to get it covers x. Okay, to get the called pre-image. Y is the image of x. X will be the pre-image of y. So that x, okay, it can be uniquely determined. Then x depends on y, and then this will be denoted by the inverse of y. Okay, you have to use a formula to describe it. Okay, so let me show you an example, such like if f is given by f of x is given by x minus 1, x plus 1. Okay, and so look at the definition of the inverse. If it exists, I think the domain of the inverse is going to be the range of the original function, and the range of the inverse function becomes the domain of the original function. It's back forward. Okay, so take a look at this function. What is the domain of this function? Domain of this function is going to be all the x cannot be -1. X cannot be -1. Yeah, because when x equals -1, the denominator is going to be 0, so it's not defined. Okay. Now the range is harder to figure out. The range. Okay. The range is harder to find out. How can I figure out the range? So the range, you're trying to see what value cannot be reached. Okay. Cannot be the whole line. Okay. So I'm not going to find the range right now at this moment. So this function is the function is increasing or decreasing. Well, you can use a derivative, right? Because you already take in math 165. So you can look at the derivative of the function. So what happens? This is not. This always stay there. Okay. All right. So you find the derivative x plus 1 square, and the derivative x minus 1 is 1 minus, and this part, and the derivative of x plus 1 is 1. So the answer here is 2 and x plus 1. This is always positive as long as it's defined. So it's the increasing function. Okay, it is the increasing function. So the inverse exists on the whole line. Okay. Sometimes be careful, it can be increasing, but on the separate intervals. Okay. But so you just need to be careful. But actually, this is increasing on any interval, connecting interval. Okay. So let's try to find the inverse. So let's consider this equation. Okay. So I'm going to solve for x in terms of y, because this gives you, given x, you get the y value. I want to reverse it. Okay. So I want to get something like that. Solve for x in terms of y. Let's solve it for x. Okay. So let's look at this. And it's going to be x minus 1, x plus 1. I'm going to multiply it. I get x plus 1 times y equals x minus 1. And I'm going to find x. So xy plus y equals x minus 1. Then this term contains x, so I have to move x to the right, and then y minus 1. Okay. So fact x out, then I find the y. Okay. x is going to be negative y minus 1 over y minus 1. So if I want to make it look good, I get x plus 1, y minus 1. Okay. So this is a relationship. So that will be the inverse. Okay. So we find the formula for the inverse, but use the y variable. So what is the domain of the inverse? The domain of the inverse is going to be y cannot be 1, right? Because otherwise its denominator is going to be 0. So I believe that this also should be the range of the original function, okay? Because if this is an axis, this is the domain of df, right? And this is a y axis, that's the domain of, that's the range of f, okay? Again, from here to here, right? The range, right? So if we reverse it, you will get reversal procedure, right? This is the inverse. They send the y to x, right? That's the picture. So the domain, as the range of f becomes the domain of the inverse. This becomes the range of the inverse. Okay. All right. So now I can, because I can easily find the domain of the inverse, so I get the range of the original function. Okay. So this is going to be the y cannot be equal 1. So let's take a look at the function again. It is going to be x minus 1, x plus 1. I want to see why this cannot be equal 1, never reach 1. Okay, this gives a value in the range, right? So I take a look at minus 1. Okay, and then I simplify. Oops. So after simplifying x minus 1 minus x plus 1, that is going to be negative 2x plus 1. All right, this never be 0. Do you agree, right? Never be 0 as long as it's defined. So that means f of x never be 1. So that's why 1 is not in the range. You know, right now I can figure it out easily because I know the answer already from the inverse. Okay, so that means 1 is not in the 1 is not going to be in the range. Actually, any other number can be in the range. Okay, so that means the range of f is going to be y cannot be equal to 1, as this implies. And any other number can be in the range as long as it's not going to be 1. Okay, so any number which is not good, yeah, you can find out. So this is another way to determine the range. But if you already know by guess and trying, you already know the range, then this. But I got this from the inverse function already, okay? Because once you get the formula for the inverse, you can easily find the domain. Then the domain of the inverse should be the range of the original function. Right? So this is about, there are some functions that does not have an inverse, okay? Before I talk about the derivatives. For example, f of x without any restriction. This one has no inverse, okay? F has no inverse. The reason is it's not increasing, it's not decreasing, and I cannot find unique way back. This is a parabola, right? So here's x. Yeah, give x, I can get a y value, no problem. That's the y value. But if I give a y value and I don't know which way is there, I got two different values. I cannot choose, right? So so x is uniquely determined by this. But this one, given y, then you cannot uniquely determine the x value. So that's why you cannot find the inverse. If you have to find the inverse, you will define some strange functions given multiple, like right, get two values always. When you give a value for y, you get two values of x, like a multiple head missile, right? One missile, okay, two heads. Okay, but we don't call it a function. We can define its generalized function, but in our in this textbook we don't consider those functions. All right, so that's why that's no function. But some functions, if without any given restriction x, then the implicit domain of the function will be the whole line. But sometimes we define the function with additional restriction x. Now this f is not that f, okay? Because already there's a restriction. So the graph of this function will be only this line, and this is increasing, right? So when you give an x, you get the y value, and the given y value can get a unique x value. Okay, so this function, we always use same name here, okay, f, because just for the simplicity. So given x, you get a y, but here x must be greater than 0, okay? Then conversely, given y, you get the x, unique x, okay? So that's x squared, that is going to be square y, okay? Yeah, so it's easy to find out. So the inverse of y is going to be square y. And the y is greater than or equal to 0. Yeah, you have to put that, okay? So the inverse exists. The inverse exists. So the next problem is, what's the relationship? If we have an inverse, right? This is the examples, and the x to y, and the y equals f of x. Let's go back to here, and this will be x. So if I go around, you send x to y, y back send the x. So that means you can also, it's going back, right? So actually, f of x is y, then the inverse, that should be equal to x, okay? Right? And you can also switch around. You get this. Okay, this is for the, you start from y, then you get x, then you send it back to the y variable. So this will be the identity. Okay, those are two important formulas for these two functions. Okay. Now, I like the second equation. Okay. Yeah, this is how do we get that? This is going to be like that. It's going to be this. Okay, given y value and get x, and then send the x back to the y. So that's why it's composite of two functions now. So this is composite. I differentiate both sides with respect to y. This is chain rule, right? Right, so that will be the chain rule. So here would be f prime, then the derivative of the inside the function, and that's going to be what? Okay, so I find the what? I find the inverse, the derivative inverse function. All right, so this is an important formula. We always test you. I'm going to do some exercise from the book. Right, so I'm going to, yeah, let's do the first problem. It's from book number 28. So we are given the function 2x squared minus 8x and x is greater than or equal to. And find the inverse function. Okay, I use a y variable, but later on you can change the x variable, okay? So you find the inverse and yeah, let me check 2 times 9 minus. Yeah, let's do that another one later. So let's find the inverse first. All right. Why this one has the inverse? Okay, if you draw the graph, okay, this is y, this is axis. So f of x equals 2x and x minus 4. This is a parabola opens upward. Here's a 4, here's 0. When x equals 2, okay, when x equals 2, that's the middle point. 2 times 2, 2 minus 4, which is going to be negative 8. So somewhere here. So this is a parabola starting from here. This is going to be vertex. I did not draw the other side. Okay, this side is not there. So this is just half of the parabola. So it's increasing. So the inverse exists. Okay, and clearly f4 is 0, right? So f4 is going to be 0. Okay, so that means if the inverse exists, then f of negative, the inverse value of 0 is going to be 4. Okay, so if I ask you to find the derivative of this at 0, okay, then yeah, how do we do that, right? The inverse is defined as 0. Actually, it's, the domain here is negative 8. Okay, so let's find the inverse. I think the domain of this function is start from 2 to infinity, right? The range of this function, because it's parabola, it's easy to see. It's from negative 8 to positive infinity. So if I find the inverse, then this becomes the domain, the other one becomes the range. Okay. So if the inverse exists, this is going to be the range. And this will be the domain of the inverse. Okay, okay, let's find out. How can I do that? So y equals 2x squared minus 8x, right? I have to solve for x. Okay. So it's good 2x squared minus 8x minus y equals 0. It's quadratic equation in x. It is quadratic equation in x. Okay. All right, so let's solve it. X equals 2a plus or minus, it's negative b, right? Plus or minus b squared minus 4ac. So we have to simplify it. I think I can take 2 out. 4 out, yeah, it's 2. And this will be this will be 16. Okay, yeah, 16. Mine plus 2, y divided by 4. Okay, so you can simplify a little bit, but that's all you can do. you can, so clearly, which piece you have to take, okay? X should be positive, okay? So X should be divided by 2 plus 1/2 square root of 16 plus 2y, okay? So this is the inverse function. Okay, this will be the inverse function. Now, from here, it's clearly, you will see that 16 plus 2y should be greater than 0. So y is greater than or equal to -8. And that gives you the domain of the function. Okay. So the domain of the inverse would be -8 from positive infinity. And that matches what we already see from the definition of the inverse function. Right. The question is, yeah, what is the value of the inverse function? From here, you can also tell that the value of the inverse function, the 0, is going to be 2 plus minus 16 plus 2 times 0 is 2 plus half of square root of 16 is 4, and that is 4. Double check, right? All right, now what is next? Find the derivative. You have two options here to find the derivative. You use the formula for the inverse function to find the derivative, but it involves radicals. It's very complicated. So I prefer to use this formula already mentioned. Okay. Yeah, this is always a formula we always recommend. Okay. And sometimes we design the problem so that you are not able even to easily find the inverse function. So you cannot use the formula for the inverse function then to find the derivative. Okay, so here f -1, 0 is going to be 4, right? So all you have to do is just find the derivative of the original function, then evaluate it at 4. But the original function is easy to find out, right? So because it's quadratic. So remember, this is going to be 8x, right? So the derivative is so simple to find out. 4x minus 8. Right? 4x minus 8. So therefore, it's a 4 times 4 minus 8. And that is going to be 8. Right? So we find the result. Right? We find the result without differentiating the inverse function, which is usually given by a very complicated formula. Okay. Now, well, if you want to do that, you can, because this is a quadratic, this is a radical function, right? So if you can try for this particular problem. Let's double check. It's plus 1/2, 16 minus 16 plus 16 plus 2y. Okay, so I can find the derivative, the general formula. This first one is 0, 1/2. And this will be just 16 plus 2y to the 1/2. So use a chain rule. It's 1/2. 16 plus 2y to the negative 1/2 times 2. Okay, 2 cancels out. So you get a general formula. Right. The next step is you can evaluate which is going to be 1 of 8. So you will see that same answer. Okay, but this time you still okay, you can find the derivative. Yeah, you can find the derivative. But we have functions you cannot find the derivative. Find the inverse. Okay. Here's a problem from, yeah. F of x equals 3x cubed, for example, and 4x squared plus 6x plus 5. Find the derivative at 5. Find the derivative of the inverse at 5. First of all, you have to make sure the inverse exists, right? At least locally. So let's do something else. Let's look at the derivative of the function. It's going to be 9x squared plus 8x plus 6. Okay, so this function, I'm not sure it's always positive or not. So let's check. Okay, so how do we know this is a positive always? I hope so. Otherwise, we have trouble to prove the existence of the inverse function. So we look at this quadratic function opens upward. If it's negative somewhere, then you must have zeros, roots, right? So let's look at the b squared minus 4ac. Okay, so it's 8 squared minus 4 times 9 times 6. And clearly, this is a negative. Okay, that means no roots. So that means this implies 9x squared plus 8x plus 6 never be 0. Okay, no roots. You cannot find the roots because you cannot find the real roots because this is if you use a quadratic formula, right? If you use a quadratic formula, this is a b squared minus 4ac is inside the radical. So if it's negative, then you have no real roots. Then no real roots means this cannot be never negative. Actually, it's always positive. Why? Because when x equals 0, it's positive, then always positive. Okay, so this implies this is always positive. This implies the function always increasing. So theoretically, this function, the inverse exists. The question is, how do you find the inverse? Now, there are some students yet trying to find the inverse. It's impossible. Then you make algebraic mistakes. And then, you're trying to find the inverse to find the derivative, right? Find the formula for the inverse. I said that there are some problems you cannot find the inverse. All right, so the inverse exists, but it's harder to find out. And even you can express it, but it's expressed by a very complicated formula. But it is expressed by a very complicated formula. I don't call it formula, complicated expression. Right. Then you will ask, how do I do that, right? How can I express it if you really want? We don't have the formula in any textbook, quadratic formula. It's not quadratic formula. But in some algebra, manual, mathematical manual for engineering, I found the formula for the roots of a polynomial of degree 3 and degree 4. Okay, it's very complicated. It involves lots of radicals. Okay, using the coefficients. But the mathematicians prove that if the polynomial degree greater than or equal to 5, the roots cannot be expressed in terms of the coefficients. Yeah. That was proved by a genius young guy. He passed away at the age 21, 19, I don't know. So anyway, you can find, yeah, I can express, but we don't want to do that. Okay. So the question is how to find this, right? So you have to use a formula. See, in this formula, you only need to know the value of this and the derivative of the original function. The derivative of the original function is easy to find out. It's polynomial. Okay, how can I find the inverse of this? So what the values of function? Yeah, for what x you get 5, and clearly f of 0 gives a value of 5. It's going to be 3 times 0 cubed plus 4 times 0 squared plus 6 times 0 plus 5, which is 5. Okay? Since the inverse exists, you can always move f to the other side, become f inverse. Okay? So the value is determined. The value is determined. So I put it there. Okay. All I have to do is find the derivative function, which is already the very beginning when I was checking whether this function is increasing. Okay. So I get 9 square and 8 0, right? And plus 6, I think. Yeah, the derivative is 9x squared plus 8x plus 6. Where it is? It's here. That's it, right? You just plug 0 for x. So the answer will be 1 of 6. You see that? You still can find the derivative without finding the expressions for the inverse function. Yeah, you have to do at least the 3 or 4 problems. You will memorize it. Otherwise, when I give a test, I still see there are 5 students couldn't do the problem. 5 students. Yeah, I remember the number. Okay, they can have no idea how to do this type of thing. I haven't seen this problem before. No, I give you the problem, and that's a homework assignment. So, yeah, and it is on the practice exam. Okay. All right, so let's take a look at the next problem. F of x equals x cubed plus 3 sine x plus 2 cosine x. I want to find the derivative of the value 2 if it exists. If the inverse exists. If the inverse does not exist, I cannot find it, right? Cannot find the derivative. All right, so anyway, we have to find the derivative. So let's go ahead to find the derivative, right? Because according, when you do the homework, you should write down the formula you're going to use. Okay, so this is going to be the formula you're going to use. So write down that first. So you get half of the credits already. That's a very important step. The next step is to find the derivative, and you also find the value of the inverse function of 2. Okay, so let's try to see how can I get a 2. I think by easy observation, f0 is going to be 0 cubed plus 3 sine 0 plus 2 cosine 0, which is 2. So if the inverse exists, then the inverse of 2 is going to be 0. But I still don't know the existence of the inverse yet. Let's look at the derivative. Right, the derivative of the function will be 3x squared and plus 3 cosine x minus 2 sine x. Oops. I think it's harder to prove the derivative exists here. Okay, we have to accept. But at least for nearby, yeah, how do you see this is positive, right? You have to prove that it's positive or negative, right? So that's a derivative, okay? So this is so let's draw the graph. We probably don't need to know this the universe exists for the whole line. Okay, when the f is 0, the y value is 2. When x is 0, so the graph passing through it's going up like that. Okay, the sine x is increasing, cosine x decreasing. So anyway. So when x close to 0, let's look at the value of 0. Okay, it's a 3 times 0 plus 3 cosine 0 minus 2 sine 0, which is going to be 3, which is positive. Okay, so that means in a small neighborhood, okay, in small neighborhood, this function, the derivative is increasing. Okay, so derivative is increasing. So as the derivative is positive, function is increasing. So the inverse at least locally exists. That's all I need. Okay. Anyway, so over this interval, if you put a restriction, this inverse exists. Okay. Otherwise, yeah. Otherwise, it's harder to tell. Okay. So the function, the derivative function is positive, so the inverse exists locally. Okay. So now 0 is going to be the value of the inverse function too. Okay. So what I got here is right. It's going to be 0 here because this is then you plug 0 for the derivative, already calculate that. It's going to be 1 over 3. Okay. You just may assume that the inverse exists. But at least if the function restricts on a small neighborhood, okay, across origin, then over there the function is increasing. So the inverse exists when it goes up and goes down, and then you can reverse it. Okay, 0 2 corresponds to 1. Right, small problems here. So traditionally, we always use x as the input variable. Okay, so in tradition, okay, so if we are given a graph of This is a graph y equals f of x. Right. So what is the graph of the equation x equals this? My opinion is these two are essentially the same. Same equation. You just rewrite the expression, right? You know, you modified. You did not change the relationship between x and y. Right? You did not change the relationship between x and y. So this equation, both of them are equations in x and y. Both two equations are essentially the same as they're equivalent. Okay, we call them equivalent equation. So they represent, that determine the same graph, no difference. Okay, no difference. But if we change the variable, okay, use a traditional input variable, use a traditional x variable for the input variables, then the graph of this will be different. Okay, it's actually it will be like that. Okay, so symmetric about, yeah, x equals symmetric about the line y equals x. Okay, the reason is yeah, let's look at the point. Okay, so what if we are given a point a and the b? If I interchange these two variables, where's this point? The point is here, b and a. Okay, so actually they are symmetric about this line y equals x. Okay, the same reason using this idea. Yeah, so if you interchange two variables of the equation, okay, and you get a totally different picture. But those two pictures are symmetric about the line y equals x, Okay, so in general, if we have equations for some curve like that, this equation can be written like this. You know, two variables. Okay, with two variables. Then if I interchange two variables, I get a new equation, and that new equation actually is symmetric. It's hard to draw it. Symmetric about yeah, okay, something like that. Okay, it's a symmetric about this line y equals x. All right, so let's look at the inverse graph for the sine function. Okay, sine function. Y equals sine x. Now, the sine function is not an increasing function, so you cannot define the inverse in the whole line. But if I restrict x between negative pi over 2 and the positive pi over 2, and over that interval, this is the increasing function. So the inverse exists. Okay, the inverse exists. I have to draw. Where's my pen gone? Okay. Okay, it's here. Yeah, I needed to draw it much better way. Okay, so the sine curve function actually is under that and below this. Okay. Yeah, this is a y equals x. All right. So its inverse exists. Then you can solve for y technically can solve for x in terms of what? So the inverse function is denoted by sine negative, right? The inverse, yeah, the inverse function is now denoted by sine negative. So sin is the name of the function, just like the f. Okay, but we use the 3 letters. Just the your name use the 4 letters, 5 letters. Okay, but we do the computer programs. If you only have a couple of functions, you don't need more than 2 letters. But if you deal with 6 billion people, right, you have to have you have the different names combination. Only first name is not enough. That's why you have family name. Okay. Even that, I find out that so many kids have the same names, first name and the last name. And if you go to any schools, you can find out, hey, Eric, for example, there's so many Erics there, one schools. Yeah. Okay. And then even last name is the same. Okay. All right. So now, so those two essentially the same equations, they're equivalent, just writing in different ways. Okay. Just like x equals 2y, then half of x equals y. It's the same equations, basically. They represent the same lines, so we don't tell them different. Here, x equals to y, and y equals to half of x. So they look different, but they are still the same equations. Essentially, they're equivalent. Okay. All right. So, but if I change the variable, that's a usual notation, right? Use the x variable. I want to draw the graph in the same picture. Then, yeah, then this is let's use a color, right? Then the graph will be here. Okay, and if this is a pi over 2, this is a negative pi over 2, and this will be a negative pi over 2. This will be positive pi over 2. Okay, so you can draw you can draw them in the same picture, same coordinate system. Okay, so those two are, the first two are equivalent, those two are not equivalent, okay, that represent different, that determine different graphs in the same equation. The reason is you view them as equations in x and y. So actually those two equations are not same equation. You interchange the two variables. Okay, this is a little bit difficult. So you can use the formula to find the derivative. I can tell you. Yeah, you can find the derivative of the inverse one. We're not going to do that here, but we will do late section. All right, so let's try to look at some other problems. Okay, so we are given this, this is find the function, right? So this is an equation given. This is for f of x. Find now, if I want to find this, you have to change the variable. Okay, so in order to get that, you can get the inverse function in y variable, then you change it to x variable. So how to do that? Well, we probably don't need to waste time to prove the derivative is positive. First of all, let's take a look at the domain. The domain of f is going to be the x cannot be negative, so it's going to be interval from 0 to infinity. Okay, from 0 to infinity. All right, then it's harder to find the range, right? What is the range of this function? It's harder to see that. Okay. But I can try the following way. I can modify this. I'm going to put 2 minus 1 minus square x. Okay. So what I get here is 2, 1 plus square x minus so that becomes 1. Okay. So clearly, this never be negative 1. Why? Otherwise, the first term would be 0. Okay. So this cannot be negative 1. Okay. So the range, it's hard. It's negative 1 is not included, but this number can be any number or not. I think that this number, the smallest value of this number is going to be 0. The largest value of this number is going to be 2. Okay. So from 0 to 2, oops. From 0 to 2, so the value of 2 over 1 plus square x changes from 0 to 2. It's always minus 1. Okay. So it's minus 1 will be negative. Yeah, it's negative 1. And 2 minus 1 is 1. I believe this is going to be the domain. Okay, let's look at it later. Okay, negative 1 is not included. All right, so I'm going to solve for x. Okay, I'm trying to solve for x, right? So I can get the inverse function. So I get 1 plus square x y. Okay. And so I move this to the right-hand side and this to the left-hand side. Okay, square x to the left-hand side and the y to the right-hand side. So I get all right, so square x is going to be 1 minus y, 1 y plus y, 1 plus y. So you square it. Okay, so that is the formula for the inverse function. So what is the domain of this? What is the domain of this? Well, yeah, be careful about this because yeah, y cannot be negative 1, but does not mean y can be any values. Okay. So you yeah, I tried to, I'm not going to cover the ranges here. So the domain of this f is not determined by the formula, by this expression. The reason is y is not the free here. See, look, we have to go back to the original expression for the function. Okay. If you look at this function, right? Look at this. So what is the possible value for this? When x equals 0, that's smallest one. It's going to be 2. right? So when x increases, it's getting smaller and smaller. So decrease to 0, but 0 is not included. Okay, so the largest positive value for this is going to be 2. The smallest positive value is never be reached, but it's 0. It's always positive. So that's why if we subtract 1, then you get a negative 1, then 2 minus 1 is 1. So that's why if you subtract 1, okay? So that's why you get domain. So this, so the domain of the inverse is going to be the range of f is going to be negative 1 and 1. Okay. So yeah. So this is a this is answer. Okay. Yeah. So be careful. You the function you're given here, the domain is not given explicitly. So the domain is a set of x for which is defined, but the range here is not determined by the inverse function. Actually, you have to look at the value, positive value of the function. Right? The positive value of the function is between 0 and 2. Right? The reason is the positive value function is for the first part is between 0 and 2, then minus 1, then it's easy to say it's between negative and 1. Okay? So those are the positive values for the function. So the range is fixed. Then this range becomes the range becomes the domain of the inverse function. Okay, but if you look at the expression itself, the inverse, the function itself, I think it's only is defined even in large, in a large interval. It's not only just from negative 1 to positive 1. Okay. If you just look at the expression, this is but yeah, forget the inverse, forget the domain. So this problem from the book, it's not. You're not asked to determine the domains. But in general, we have to. Yes, you know, if for a complete solution, you have to include the domain and the range. Okay. Yeah, I stop here today. So I will post my syllabus